As hard as we try to provide good customer service and quality manufacturing, the truth is that there will always be cases where a customer needs to spend much more than the average time at a station. The extra time could be due to poor communication or bad luck, but the result is the same. These longer turns at a station are called rework loops. In this movie, I will show you one way to incorporate rework loops into your simulation. My sample file is chapter 0506, and you can find it in the chapter 5 folder of the exercise files collection. I haven't made any changes to the sim setup workbook. If I wanted to, I could assign a probability of a rework loop for each station, but in this case, I'll just keep it simple and hard-code it in the VBA code itself. I did make one important change to the results worksheet, so I'll click there now. And you see that over on the right-hand side, I am keeping track of the rework assignments. So I have the customer ID, the station, and the rework time. So we'll need to add code to write out those results. With all that in mind, I'll press Alt F11 to move to the Visual Basic Editor and get to work. I have renamed the Module 2 code's subroutine rework loops. I've created a few more variables. You can see here at the bottom of the declared loop counter, random, and processing time variables, I have added a rework time variable and also a rework counter. So I'm keeping track of how many rework assignments we have. So I'll keep scrolling down here. And I have indicated here that the rework counter should be initialized to 1. And then within the body of the simulation, if I scroll down, I have a comment indicating where I should put in the rework loop instructions. And the rework code goes in the place right after the customer has spent all of their initial time at a station. And then with what will be a 5% probability, they might have to go through again and have a random stay in that station as part of the rework loop. So the first thing we need to do is check to see if they, in fact, do need to go back through the station. So we will generate a random number. So it'll be SNG rand, which is a variable we've used before, but we can reuse here, equal RND. So just a random floating point number between 0 and 1, and enter twice. We'll use if-then logic. So we have if SNG rand is less than or equal to 0.05, then, and we'll get into the body of the rework loop itself. So we have L rework time. So the amount of time the customer will spend in the rework loop equals, and here we need to use the inverse of the normal distribution again with our random variable. So what we're doing is we're using a normal distribution with an average or mean and a standard deviation to use our random variable to calculate the time based on those parameters. And this is a fairly long command, so I might need to break it off into a couple of lines. So application dot worksheet function period norm underscore inv. Then in left parentheses, we have the first argument, which is sing rand, our random number, then a comma. And I'll go ahead and type a space, underscore, and another space so I can go to the next line and indent by 2. And we have stations, objc, so our customer dot station, the station the customer is currently at, left parentheses, or excuse me, right parentheses, period, sta mean, so the average time they would spend in that station. Now we need to do the same thing for the standard deviation. And instead of sta mean, we'll copy everything before that and type sta sd. Then a right parentheses to close that out. And it looks like that is the end of the command. Yep, we have the random variable, the mean, and the standard deviation. So I'll press enter and go back. And one more space. And we need to make sure the customer spends at least 1 tick in the rework loop. So I'll type that as a comment so everyone knows what I'm doing, especially me when I come back to this later. So I have f L rework time is less than 1, then L rework time equals 1. Very good. then enter twice, and now we can calculate the new end time. So that would be objc.end time equals itself plus the rework time. So objc.end time plus L rework time. Right, that looks good. With that in place, we can write out the results for the rework loops that actually occur. So enter twice and write out rework time results. So worksheets, and again, we're on the results worksheet. So in parentheses and double quotes, results dot activate, and enter active sheet dot range, and the cell at the top left corner of the rework table that we're creating is cell J1. So I'll put that in double quotes. For the range, we need to activate that. And now we can write out our three results. So we have active cell dot offset, and again, we're using the count of the rework items to tell us how far to move. Left parentheses, our row offset is L rework counter. So that'll be 1 for the first one, 2 for the second one. And we're moving 0 columns over in this case. So we're staying below J1 dot value equals objc dot customer ID. Now we can use variations of that last line for the other two properties. So I'll just go ahead and copy that to save us a lot of typing. One column to the right. So we have L rework center, which is the number of rows, and then one column. That value will, instead of being customer ID, will be the station, and that is where the rework occurred. Then enter and Control V. Now we'll go over 2 columns, and instead of the customer ID, it will be the rework time. And it's not part of the object variable. It's not a property. It's just the variable. So we have L rework time. That's an easy mistake to make. Always make sure that a variable you're using is not an object property. So if you type objc.L rework time and you get an error, then you'll know what happened. It's an easy mistake to make, and you can see that I almost did it myself. All right, so everything is good here. All we need to do now is to increment the rework counter. So L rework CNTR equals itself plus 1, and we can close out the if statement. Very good. So this is a fair amount of code, but we've added some important functionality to our simulation. Now we have accounted for the possibility that a customer might need to move through a station multiple times. It's not the ideal, but it is realistic in the world of customer service and manufacturing.